So I would like to start this presentation by thanking the Center for Undergraduate Research in Mathematics for allowing us to have the ability to do this research at both colleges. The two colleges that collaborated in this study was Humboldt State University and also Sacramento University. The Humboldt State people will not be here today, only the Sacramento State people. And the people at Sacramento State are Lily Shebrel and Lance Johnson. We were under two faculty members, one from Sacramento State and one from Humboldt State. From Sacramento State, we have Shainita Ghoshhajra, and from Humboldt State, we had Abir Hassan. Our project is on topological data analysis, which gives us a way to visualize larger and higher dimensional data without the complexities of having noise and outliers. It has the ability of removing those so we can just see the raw data in the form that we need. Our data sets are COVID-19 and US wildfires from the 1950s to present day. Specifically, we wanted to look at what the visualization of the wildfires looked like when we compared acres burned to location of each fire and what that meant. And for COVID-19, we wanted to see what the visualization of ICU occupation was and how they differed between states. In this specific poster, we are looking at California and then how that state's response to COVID-19 affected that visualization. And now I will hand it off to Lance Johnson to talk about the algorithm that we used.
Thank you. So the primary algorithm that we utilized in our analysis is the mapper algorithm, which is a tool whose goal is to take high dimensional and complex data, which it may be difficult to work with, and convert it down into a simpler structure, such as a two-dimensional graph. This allows us to see the shape of high dimensional data and detect how it is connected to itself. The algorithm works in three phases, which are visualized in the lower left-hand corner of the poster. The first phase is to take in our data as a point cloud, which here in our example, we have data points arranged in sort of a circular shape, and then to bin the data into overlapping bins, which in our example, we have three bins, the red bin, the green bin, and the blue bin, with purple data points representing points that are in more than one bin. The next step is to cluster the data within each bin. So in our red bin, we have a single cluster. Within our green bin, we have two clusters. And within the blue bin, we have a single cluster as well. The third and final phase is to convert our information into the graph, which we do by associating each cluster with a vertex in the graph, and then representing overlap between clusters as an edge in our graph. This gives us our final graph as an output. The mapper algorithm is primarily used as a tool in exploratory data analysis that allows us to gain insights by looking for the structure in data. I will now pass it back to Lily to describe the wildfire data.
Thank you. So in the upper image of the US wildfires, we have a graph visualization of the United States with each fire that we had placed on it. The darker colors represent smaller fires and the lighter colors represent larger fires, also visualized in the largeness of the circle of each. We decided to place those circles in the way that in this place that they are, depending on the average GPS location of each fire. Underneath that, we have a mapper algorithm that gave us three three-dimensional clusters because we used a 3D mapper. The lowest cluster represents the Midwest because those have smaller fires and are closer together. So all that cluster just represents the Midwest because they have very small fires and they're all very close together. And the two other clusters represent the West Coast because those have much larger fires that are closer together. And now I will pass it back to Lance to talk about COVID-19.
Thank you. So for our COVID-19 research, we wanted to look at how the ICU staffed occupancy changed over time in various states. For this poster, we show the data for California. So our data is specifically how many ICU beds are occupied, and they must be staffed, so they must have the required staff and not just be left unattended. We then used a two-dimensional mapper algorithm to generate the graph that's visualized in the lower half of the poster. And what we saw here is three disconnected pieces where each piece represents a period of relatively stable rates and separated by rapidly changing rates of ICU occupation. Our hope as we continue the analysis is to gain more insight by comparing these pieces to changes in response to COVID-19 and other potential factors. So we will be continuing to do research on both of these topics and looking to gain further insights. I would like to thank you for your attention and listening to our presentation. Thank you.